Hello, I'm Ohara from the Development 4 Center, and I'd like to share a story of rewriting 8-year-old Perl product to Kotlin. Before starting the agenda, let me introduce myself. I'm Ohara. Joined the company in 2018, writing Perl and Kotlin code even right now. Here is the agenda. First, I will introduce Line Point Club, the Perl product that we have written to Kotlin. After that, I will explain why we wrote Perl to Kotlin and show you an overview of the rewritten system. Fourth, I will briefly introduce how we managed the project. Finally, I will discuss the difficulties and insights that arose during the project and the benefits of rewriting to another language. After my session today, you will get the full picture of the migration project. If you are developing a new service, you may feel this is not your topic, but the system which you are developing will surely become outdated. So this session is applicable to everyone who is developing any system. I hope you enjoy my presentation. First of all, I'd like to introduce you to Line Points Club, a project that we have rewritten from Perl to Kotlin. You can access the Line Points Club by tapping the Points Club icon on the Wallet tab on the application. It's a portal service that provides various missions for making payments with Line Pay and accumulating Line points, a point that can be used for various Line services, as well as providing information on how to use them in linked services. Line Point Club was first launched in June 2013 as Line Free Coins. Line Point Club has Earn tab and a Use tab. Earn tab allows you to accumulate points. You can earn points by watching videos, installing applications, and so on. In the Use tab, you can exchange your points. For example, you can exchange them for Line manga coins, music coupons, and many other things, so please use them. Let's talk about traffic. On average, we get 700 requests per second, 15,000 requests per second at peak time, and about 57 million requests per day. However, the number of requests is based upon a randomly selected period of time, so there are days when the number is higher or lower than what is shown on the screen. This is a simplified diagram of the server-side system configuration of the Perl. The upper part is Internet. When a request comes in from outside, it is received by the load balancer, and Nginx proxies it to the application in Earn tab and Use tab respectively. It consists of two separate databases, one for Earn and the other for Use, and each application returns its contents. The Earn tab is written in Perl, and the Use tab is written in Kotlin. The reason why the languages are different is due to their history. Earn tab started its service in 2013, while the Use tab started in April 2015. By the way, when the service was launched in April 2015, the Use tab was written in Java, but it was rewritten in Kotlin in 2020. There was the difficulty of managing two applications in different languages, the allocation of engineering resources, and the need to develop the same function for both tabs. Since this session is mainly about rewriting the Perl product, I will explain a little bit more about the Earn tab. Here is a slightly more detailed system overview of the Earn tab. I will introduce them one by one. First, the media admin and CV worker applications are written in a framework called Amon 2. And the application called HBase Gateway is written in Kotlin Java and uses a framework called Spring Boot. You may wonder, hey, you said it was Perl Product, but you already have Java Kotlin. There is a historical reason for this. We couldn't use HBase directly from Perl. So we had to use HBase Gateway from Perl to operate HBase. We'll talk about this HBase issue in the section where we talk about why we wrote to another language. Let's go back to overview. MySQL for job queue. When a user meets a condition to earn points, such as watching a video in the Earn tab, the conversion data is enqueued into the job queue. The job queue is stored in MySQL table and CV worker processes it. Finally, we also used MySQL as database and Redis and Memcached as CacheDB. Now, let's talk about why we rewrote Perl to Kotlin. The reason why we chose Kotlin in the first place is quite simple. Java Kotlin is the most used language for server-side development in our company. The team next to me also writes mostly in Java Kotlin. Choosing the same language has many advantages in terms of allocating engineering resources and using the internal ecosystem. That's why we chose Java Kotlin. So why didn't we choose Java? The reason is that we wanted to match the technology set with other products that our team was developing. Let me tell you why we decided to rewrite Perl to Kotlin. First of all, the configuration of the system was becoming more and more complex. As we talked about this when we showed the overview of the Perl system, it was implemented in the different languages for Earn and Use tabs, and Perl needed to manage the gateway application to use HBase. Secondly, over the past 8 years, various functions have been added and changed or removed, and the functions themselves had become increasingly complex. There were also many features that were already unused. Thirdly, due to the small number of Perl engineers, I could see a future where it would eventually be impossible to continue development. Fourth, before we started the project, it looked like there would be no major changes for the next 6 months, so we decided now was the time to work on it. It was a positive reason. Fifth, the number of people who maintain Perl libraries is decreasing, and client libraries for recent middleware are not abundant. For example, we tried to use HBase from Perl some years ago, and there was no client library that worked well at that time. So we tried using Swift to use HBase and so on, but it did not work the way we wanted it to. And we ended up implementing the HBase Gateway in Java Kotlin. We couldn't handle Redis clusters well from Perl either. I'd like to add that I like Perl, and I don't mean to say anything bad about it at all. It's just that in our case, we did not get the results we wanted to at that time. It may work better if we tried it now or if we use it in another project. This is the system after the rewrite to Kotlin. In a nutshell, it looks like this. I will talk about it in order. First of all applications are implemented with Spring Boot Kotlin. The database in the bottom right corner is the same tab used in the past for Earn and Use tabs. Let's talk about what is new. Communication between applications is now done via gRPC. For those of you who are familiar with it, it is useful to serialize data in protocol buffers for fast communication and to generate code on the client and server side respectively from the API specification defined in the IDL. The data in the point cloud's earn tab is complex and some of the data sizes are quite large, so it was quite an advantage not to suffer when exchanging such data between applications. Next, we introduce Kafka as a job queue. In the Perl days, we used MySQL. This gave us better scalability and also allowed us to add another consumer to do different processing. I will talk about HBase. The HBase gateway application that we used in the Perl days is no longer needed and the management cost has been reduced. HBase can now be operated directly from applications such as Core and CV Worker. This section describes the admin application. The admin application takes the data of the earn tab to be stored in the MediaDB. It also takes the data of use tab to be stored in the MediaDB. In other words, the MediaDB is a layer that absorbs the difference between the data of the earn tab and the use tab. As a result, the media application is now able to return contents for both earn and use tabs. In thinking about media application to be Kubernetes in the future, by connecting only to the Redis cluster, it is highly scalable. Now, I'd like to talk about how we manage the project. First, let me introduce the members of the development team. We had 6 engineers working on the project. 3 were Java Kotlin engineers and 3 were Perl engineers. Java Kotlin engineers have a lot of experience in Java Kotlin and Spring Boot development. They don't know much about the specification of earn tabs in Perl. In the early stages of the project, the Perl engineers also helped us to set up the environment so that the development could run smoothly. Without them, it would have been difficult to complete the Remake project. So when we rewrite the language, we need the engineers of the new language. In our case, the Kotlin engineers. As for the Perl engineers, they roughly know about specification of earn tab. In the early stages, they were mainly responsible for writing the specification. I will now talk about how we structured the management and planning of the service during the project. First, we decided not to make any new changes to the old system. If there are any change, they would need to be applied to the rewritten Kotlin system, which would increase the development effort, and the rewrite would never be completed. It was helpful that our planners and operation side members understand this. During the project, daily meetings were held by the development side, but it was good to have the planners participate as well, as it allowed us to make decisions on specification changes quickly. The schedule for this project went roughly like this. First, the project started in January of 2021, which is this year. The development of the core application was completed around April. The core application is the green core part in the middle of the system overview. Back to the schedule. We completed the development of other applications in August. By other applications, I mean this green application part. Then we did integration and QA in August and September. The main part was released on September 27th, 2021. This is what the schedule looked like. Let's move on to the last agenda. We'll talk about the difficulties and findings that occurred during the project and the benefits of rewriting in another language. I will show you again the diagram of the schedule in chronological order. First, we will talk about the difficulties in the early stage of the project. After that, we'll talk about the learnings that came to light as the project progressed to the mid to late stages. And then, talking about the difficulties in releasing. Finally, I will talk about the benefits of rewriting in another language. Let's start by talking about the difficulties that arose at the beginning of the project. Before getting to my point, I want to ask you a question. Rewriting a product is a lot like moving. What is the first thing you do when you start packing boxes for a move? You make a list of what you have and choose what to throw away, right? I don't think anyone moves with packing everything you have. So, the first thing which we did was to identify the functions to be discarded. There were a lot of complex features that have been implemented in the product over 8 years, and there are many unused functions. It was a difficult task to find out if these are being used or no longer needed, decide to discard them, and reflect them into the new specification. In addition, it was necessary to consider how to create those that are still in use today but were forced to be created due to the manpower required when it was first developed. Second, it was hard to get all the members of the team to agree on the function to be discarded. What actually happened was members implemented a feature that was decided to be discarded by another member. The reason why this happened was that the documentation contained specifications that needed to be met but did not describe of those which were to be discarded or removed. And then while migrating the Perl code, we accidentally implemented in Kotlin. The reason why we needed to read Perl is explained in the next page. Here's how we have addressed the sharing of deleted features. We have started to write about the deleted features in the wiki and others, and also make sure to write comments on the Perl code. Specifically, we created a branch in Perl for the migration to Kotlin and made a draft pull request to write comments. This was a pretty good method, so I recommend it to you. So far, we have talked about the discard function. Next, I will talk about the difficulties of Perl for Kotlin engineers.
Why in the first place do Kotlin engineers need to read Perl? Because the specifications are not well documented. Why? Well, when the speed of adding and changing features was fast, we didn't have time and human resources to document the specifications, and also some special features were made for some ad hoc needs. This can happen to any products. Sometimes you cannot avoid it, but documentation is something that you really spend sufficient time. In this project, we began documenting specifications. Kotlin engineers find it very difficult to read Perl. I repeat myself, I love Perl, so I'm not dissing Perl. So these examples are for a little fun. The first one is defined or operators. Look at this code. You find double slash. Do you think it's a comment? Well, it is not in Perl. It is defined or operator. What it means is $params content type before double slash is used when it is defined, and if not, TSV following it will be used. Kotlin engineers really scrambled over it. I was laughing. Next is about symbols. In this code, you find lots of symbols, and Perl engineers wouldn't have any difficulty understanding them, but non-Perl engineers are overwhelmed by a large number of symbols. Dollars, ats, percents, lots of them. And then href. It's hard to see the content of it. It's not really only Perl, but it applies to any dynamic typing language. href stands for hash reference. It's a library type. At the bottom, you see sub another logic. Sub means subroutine, equivalent to functions in other languages. But what is the content of dollar data? In order to know it, you have to find the code which calls another logic. In the middle, you see logic. And you find that it is used in create data, so you then go to find create data to understand what's inside it. Lastly, I would like to talk about difficulties of Spring Boot with Kotlin for Perl engineers. So it's not really Kotlin, it's Spring Boot. That was rather tricky. Perl engineers got used to Kotlin itself rather quickly. No class def found error is something that we encountered a lot. In Perl, you can import anything by just writing import xxx. But in Spring Boot, if you do that, you get no class def found error. So you have to learn bin, di, component scan, and other features of Spring Boot in order to implement imports. So I talked about difficulties in early stage of the project. And certainly there were lots of learnings as time went on. Now, one regret we have is that we used too many nullables. The background is the Perl's variables are like Kotlin nullables. Perl variables can become undef anywhere. Undef means null in Kotlin. It can be undef anywhere, so you have to apply define checks all the time. In this project, basically, we wanted to have a common logic to import to Kotlin, so we tend to define variables as nullables. Let me talk about nullables and non-nulls. A non-null, as you can see on the top, a variable without a null. If you try and enter null, you get compilation error. On the other hand, nullable allows null. Just like string question mark, you add question mark to declare nullable. Nullable will not give you error if you set null in the code. But if you use too many nullables, what will happen? Well, more nullables mean more null checks. You may have checked a variable for null check, and sometimes you have to repeat the process without a reason. And also, converting nullable to non-null must be well considered. For example, not null assertion operator requires a caution. Not null assertion operator throws null pointer exception if null, and it is written as 2 exclamation marks. So here is an example of a poor use of not null operator. For example, you have some method which calls validate data and then calls do something. Within validate data, campaign ID is checked for null. And within do something, for campaign ID, not null assertion operator is used. In validate data, null check is done. So, campaign data is assumed not to be null, and under that assumption, do something was implemented. So, a null check is written away from the assertion operator. What's wrong with it? Well, it's rather easy to imagine. Think about adding another method. Campaign ID null check is not done when calling do something. As a result, not null assertion operators position experienced unexpected null pointer exception. This is something a developer has to be careful about. But you really have to be extra careful. Otherwise, you tend to face this. So what should we have done? We should have used non-nulls as much as possible. An example would be doing null checks on controller and give non-null to the service layer so that you can limit the scope of nullable usages. Another thing is not null assertion operator needs to be used with the assumption that the null pointer exception can be thrown. However, the use of nullable made it easier for us to rewrite from Perl to Kotlin. Now, here is the second regret. That is about handling of similar variables. Our product has a variable called digest, and which can mean multiple things. It's like tokens used for each combination of user and campaign. Under digest, there are multiple kinds. You don't have to memorize them. Limited digest, unlimited digest, line digest, and external line digest are some examples. Don't try and memorize them. At the beginning of the project, we handled all the above digest as string. As a result, later on, we could not figure out which digest was in the first format. In order to address that confusion, we began using type alias. Type alias, as indicated, is line digest string equals string. So it is a declaration that it is an alias for the string, as you can see at the bottom. On the left, without type alias. On the right, using type alias, the code becomes much readable. But type alias is an alias. In this case, a string alias. Any string is allowed. Actually, what we should have done is to use inline class instead of type alias. Inline class, as indicated, looks like this. Value class name to limit the length or to grow method as branches. We did not have time to do this, but later on we hope to use inline class to rewrite the code again. So that's been about regrets we had about writing in Kotlin. The third is about design. Business logic knows the outer world. This is often heard in clean or hexagonal architectures. You may have heard of it. In our project, what was the situation? Some business logic was throwing status runtime exception for gRPC. In other words, the business logic knew how to communicate with the outside. So let me describe what the problem was. Some logic was to be used for another application, but that application did not use gRPC. With that gRPC, IOgRPC package probably should have been added as dependency? Well, no. For status runtime exception, we shouldn't add IOgRPC as dependency. Instead, we should have made sure that we did not use status runtime exception. As a result, we had a difficulty of making logic common. How did we come into this situation? In the early stages of the projects, we were writing codes focused on the normal behavior of the system. We did not pay enough attention to the exception behavior. And we weren't aware of removing gRPC-dependent code from business logic. And we did not give enough thought about making logics common to applications without gRPC. In the end, when we wanted to make the logics common, we did not have time to clean it up. What should we have done? Well, in our case, we should have avoided using IOgRPC status runtime exception in the common logic. And we should have separated the layers that know how to communicate with the outside world and those that don't. To generalize, as often said, business logic should not know the outer world. There were also some difficulties related to releases. I'll give you 2 examples. The real QA considering the actual Perl system was difficult. Real QA is a production environment QA, and we just called it Real QA. If we were to replace all the databases, then it was not necessary to think about the current system, but that was not the case in this project. As we considered how to migrate, the best option was to use the existing databases. If we were to replace all the databases, then we would have faced other types of difficulties. So, we had to be careful about certain things. Number 1, in order to ensure we don't have incompatible data, we ran Perl and Kotlin in beta for a long time, in parallel for about 1.5 months. And during that time, we found many challenges. And some suggested we should have spent more time for it. And then, since we are adding new applications to existing systems, we verified the number of MySQL connections from the new server. The second difficulty we encountered was developing the parts left in Perl. If that was a one-time go, we wouldn't have faced this difficulty. But if we were to do it, then it would have required another 3-4 months. But it's really difficult to stop other requests for services while doing it. So partial releases and meeting inquiries and requests were necessary and better for services. So what is to be left in Perl and how to handle what is left in Perl is something we really considered well. Lastly, I'd like to share with you some benefits of rewriting using different language. Four of them. Number 1, unused features were all refreshed. That was good. And number 2, there were engineers who joined newly. Therefore, they required well documentation of specifications. And we were conscious of documenting the specifications during the whole process. Number 3, we used Kotlin, which is used widely, which allowed knowledge exchanges and mobility of engineering resources. And number 4, at the time of rewriting, we used the modern technology sets. Therefore, we updated the skill sets of engineers. So, in conclusion, I talked about this project of rewriting 80-year-old Perl product with Kotlin. The longer the service continues, the more complex the system becomes. It is not anyone's fault. The optimum options were taken at a time, but then complexity is the result of it, together with maintenance time. I introduced some difficulties of rewriting in a different language and how to resolve them. And there are many insights and benefits gained from the project. I encourage you to review your code and document your specifications while sometimes deleting unnecessary features. Thank you.